Most people look at a WNBA player prop and start with the last 5 box scores. I start somewhere else. I want to know what the player is being asked to do tonight, how stable that role really is, and whether the number on the board matches the situation underneath it. That is where AI becomes incredibly powerful. It can read more information, compare more angles, and connect details that are easy to miss when you are scanning a slate on your own. The goal is not to ask a chatbot for a green light and blindly press over or under. The goal is to give AI the right problem. A WNBA player prop is not just a prediction about points, rebounds, assists, or threes. It is a prediction about minutes, possessions, usage, shot attempts, matchup, rotation, and game script all arriving in the same direction. When AI evaluates those pieces together, the analysis becomes much more than a box score guess. Here is the first thing I ask it to solve: what is this player's actual role? A scoring guard with the ball in her hands every possession has a different prop profile from a wing who depends on catch-and-shoot opportunities. A starting center who normally plays 32 minutes is a different bet from a backup who can finish with 20 minutes even if the matchup looks perfect. The line may say points, but the real question is workload. That means I want the model looking at recent minutes, starts, usage, shot volume, assist chances, rebound chances, foul risk, and the player's rotation pattern. I care about the distribution, not just the average. If a player has been close to 20 points because she played 36 minutes in competitive games, that is useful information. If the same average came from a few hot shooting nights while her minutes and attempts moved around, it tells a very different story. The second layer is the matchup. This is where surface-level analysis usually loses me. It is not enough to say that an opponent allows a lot of points. I want to know where those points come from, whether the defense gives up attempts at the player's position, whether it protects the paint or allows perimeter volume, and whether the likely defender changes the shot profile. For assists, I want to know whether the defense sends help and whether the player's teammates convert the look she creates. For rebounds, I want to know about lineup size, missed shot opportunity, and whether the player is actually in the action near the glass. AI is useful here because it can compare the matchup with the player's normal role instead of treating every opponent's stat as equally important. A defense can look generous overall and still be a bad fit for one specific prop. The reverse can happen too. A supposedly difficult matchup may create exactly the kind of possessions that a player's role is built to exploit. Then I add the game environment. Pace matters because more possessions create more opportunities, but pace by itself is not a bet. I want the model to connect pace with minutes, offensive responsibility, expected competitiveness, and the chance that the game stays close enough for the main players to remain involved. A fast game with a blowout risk is not automatically better than a slower game with secure minutes and a clear role. This is also why I do not treat a player's recent streak as a complete argument. A streak can reflect a real change, like a teammate being out or a coach handing someone a larger role. It can also be a temporary shooting run that the market has already noticed. AI can separate those possibilities much faster when it has the underlying game logs and the surrounding context in front of it. This is where I use parlai. Parlai is built for this exact kind of sports betting analysis because it gives the AI live context instead of making it reason from a frozen box score. I can bring in current statistics, injury information, lineup and rotation news, and matchup details before I judge a player prop. I can choose one AI model when I want a focused read, or use a full panel of models to compare different interpretations of the same line. The difference is not just getting more opinions. Parlai lets me challenge the reasoning in a live chat, ask what assumption is carrying the prediction, and look at the pick in the context of previous results. When a read misses, that loss becomes part of the reflection instead of disappearing into a pile of old slips. That feedback loop is what makes the tool more useful over time. You can check it out at parlai.cc. Now let me show you how I apply that process to a fictional example. Imagine a guard is listed at 19.5 points. The first question is not whether she scored 20 or more in her last 3 games. I ask AI to establish a baseline using her normal minutes, attempts, free throw opportunities, and roll with the current rotation. Then I ask what would need to change for her to clear the line tonight. Maybe the matchup increases drives but lowers open 3-point attempts. Maybe a teammate is questionable, which could raise usage but also bring a more aggressive defense. Maybe the game is expected to stay close, which supports minutes, while the opponent's coverage encourages the player to create for others instead of forcing shots. Those details can pull the projection in opposite directions. The best AI analysis does not hide that tension. It explains which factors matter most and how sensitive the projection is to each one. Next, I ask for a range instead of a single magic number. If the model projects 20.8 but its reasonable range runs from 16 to 25, that is not the same kind of confidence as a tighter projection around 20. The mean can look attractive while the uncertainty is doing all the work. I want to know the probability of clearing the line, what assumptions create that probability, and which piece of news would change the answer. This is where a panel of models can be valuable. One model may emphasize the player's recent usage. Another may notice the matchup creates more assist opportunities than scoring opportunities. A third may focus on minutes risk. I am not looking for a unanimous answer just because it feels comfortable. I am looking for agreement on the important facts, disagreement that exposes the fragile assumptions, and a final read that is grounded in current information. The same process works for rebounds, assists, three-pointers, and combination props, but the inputs change. Rebounds require missed shot volume, lineup size, and positioning. Assists require ball handling responsibility, teammate shot quality, and conversion. Threes require attempts, defensive coverage, and whether the player is creating those attempts consistently. AI gives me the analytical ability to organize all of that without losing the thread. Before I make a decision, I run one final check. What is the number? What is the player's expected role? What is the range of outcomes? What news could change the minutes? Does the matchup create the exact opportunity this prop needs? And is the price giving me enough room for the uncertainty that remains? If I cannot answer those questions, a confident-sounding projection is not enough. That is how I use AI to bet WNBA player props. I am not outsourcing the decision to a random prediction. I am using AI to build a deeper information set, compare models, surface the details that matter, and pressure test the story behind the number. The edge is in the analysis happening before the pick, and parlai puts that analysis, live context, model choice, and feedback loop in one place. If you want to see how I evaluate more sports betting situations with AI, subscribe to Professor Parlay. And if you want to run the same kind of live, context-driven analysis for your own picks, visit parlai.cc.